So today I'm going to teach you the quotient rule. So it's the third of the three rules. We talked about the chain rule, the product rule, and now it's the quotient rule. Right, so product means two things multiplied together. A quotient is when something is divided. So in this case, when we have our function, it's going to look like f over g. So f and g are both functions with an x in it. So today when I did that example, that was a rational function. It didn't have an x on the top line. So we shouldn't use this method to do those sort of problems because they're much easier done if you just take the bottom line to the top like we did in that example. So this one will have a function of x over a function of x. We call one f and one g. And you'll also notice that yesterday I said f dash g plus g dash f. And so the same thing works today, but this time it's a minus. F dash g, take away g dash f, and g squared. So that's the formula that you'll be given in the exam. It's on a piece of paper. Looks exactly like that. Well, pretty much exactly like that. And you get used to using it. So let's have a look at an example. So the first one I've got is y equals 3x over 4x squared plus 1. All right, so this is our f and this is our g. So f dashed and g dash will equal 3 and 8x. So once we've done our little table, I suppose, of what we've got, we need to put it all into the formula. So dy by dx. I like that one the most out of all of the notations because what it actually says is the y that you've been given differentiated with respect to the x's in it, and they'll come into play a little bit further on. Okay, so putting it together, f dashed in brackets all the time, g in brackets 4x squared plus 1 minus in brackets g dash 8x and in brackets f 3x and all over g 4x squared plus 1 squared. And we will leave it there, guys. We won't change that into, there's my black pen gone. Over there. We'll leave it looking exactly like that. Now here's the biggest problem. They're not going to leave it looking like that in the answers, so it's going to be hard for you to actually check if you're right or not, because the answer in the book will look quite different, but it takes such a long time to get to that answer and it's such a lot of algebra, and we're not actually interested in that. They're interested in whether you can do the quotient rule. So that's the first example. Second example, a little bit more complicated. Y equals 3x squared plus 1 squared over 5x. All right. So the reason that it's more complicated is because we've got a chain rule on the top. So we need to change that into something else before we differentiate it. So we'll not change it. We need to differentiate it slowly. So f dash will equal, take the 2, multiply by it, 6, leave the present, x squared plus 1, take 1 away, 2 minus 1 is 1 and we don't write it down, differentiate what's inside the bracket, 2x. And you can see we're getting lots of brackets now. 5x differentiated is 5, left that nice and simple so we don't get too complicated. And then put it together using the formula. So dy by dx, lots of brackets, equals f dash 6 x squared plus 1 bracket 2x times g 5x minus g dash, put it in a bracket 5 f bracket 3 bracket x squared plus 1 squared bracket. All right, make sure your starting and finishing brackets are equivalent, so you've got a balance of them, and the bottom line squared. And we don't do anything from there because whoever's marking it is going to say, okay, is that f dashed, is that g, is that g dashed, is that f? So they're going to check off the points that, yep, this person knows how to use the quotient rule, and yes, you can substitute into that really easily, so you don't need to go anywhere else, and we don't want to be making mistakes. All right, so I'll set some work up for you, and we'll see you next Wednesday, first period for our Google Meet. So that'll be 9:30. Ciao.